Welcome to Gartex Electronics channel. Today we will discuss briefly about Zener diodes and their uses. From our previous tutorial about diodes, we said that diodes allow current to pass only in one direction. We also said that diodes are made of p-type and n-type materials, hence forming a p-n junction diode. A normal p-n junction diode is usually fabricated by adjusting the p-type and n-type semiconductors on a single semiconductor crystal. The characteristics of a junction diode show that it is designed largely for operating in the forward direction. Applying a large amount of forward bias causes greater forward current with a small value of forward voltage. However, it should be known that, reverse biasing the diode do not cause conduction of current till high values of reverse voltage are reached. If for example the reverse voltage is large enough, breakdown occurs and a reverse current starts to flow. Hence, this minimum voltage that is required to make the reverse current to start flowing in a diode is called breakdown voltage. Ordinary p-n junction diodes are generally damaged when this breakdown occurs. The flow of current in Zener diodes is controlled by the minority charge carriers under the reverse bias condition, so they can also be referred to as breakdown diodes. During specific conditions of fabrication, a special type of diode is formed that will not be ruined when the breakdown voltage is increased, given that the current does not exceed a defined limit to prevent the case of overheating. This type of device is referred to as a Zener diode. The breakdown voltage of a Zener diode is carefully set by controlling the doping level during manufacture. If the diode is heavily doped, Zener breakdown occurs at low reverse voltages. On the other hand, if the diode is lightly doped, the Zener breakdown occurs at high reverse voltages. Zener diodes are available with Zener voltages in the range of 1.8 volts to 400 volts. Therefore, we can conclude that a Zener diode is a silicon semiconductor device that permits current to flow in either a forward or reverse direction. The diode consists of a special, heavily doped p-n junction, designed to conduct in the reverse direction when a certain specified voltage is reached. Additionally, the voltage drop across the diode remains constant over a wide range of voltages. It is this feature that makes Zener diodes suitable for use in voltage regulation. Zener diode is heavily doped than the normal p-n junction diode. Hence, it has very thin depletion region. Therefore, it allows more electric current than the normal p-n junction diodes. The Zener diode operates just like the normal diode when in the forward bias mode, and has a turn-on voltage of between 0.3 volts and 0.7 volts. However, when connected in the reverse mode, which is usual in most of its applications, a small leakage current may flow. As the reverse voltage increases to the predetermined breakdown voltage, a current starts flowing through the diode. The current increases to a maximum, which is determined by the series resistor, after which it stabilizes and remains constant over a wide range of applied voltage. Zener diodes allow current to flow in the forward direction in the similar manner as an ideal diode, and also it permits current to flow in the reverse direction when the voltage is above a certain value known as the breakdown voltage. This voltage can also be referred as Zener knee voltage or Zener voltage. A Zener diode allows electric current in forward direction like a normal diode, but also allows electric current in the reverse direction if the applied reverse voltage is greater than the Zener voltage. So, a Zener diode is always connected in reverse direction because it is specifically designed to work under reverse bias. Zener diodes are the basic building blocks of electronic circuits and widely used in all kinds of electronic equipments to protect electronic circuits from overvoltage. The symbol of Zener diode consists of two terminals, cathode and anode. In Zener diode, electric current flows from both anode to cathode and cathode to anode. The symbol of Zener diode is similar to the normal p-n junction diode, but with bend edges on the vertical bar. How do you connect a Zener diode? Zener connected mainly in the reverse bias mode by connecting anode to the negative terminal of the power supply and the cathode to the positive terminal of the power supply. It is important to remember that Zener diodes are categorized and rated by the voltage at which they will turn on or start to conduct the reverse bias current.
Thank you for watching this tutorial. We shall continue with this tutorial in the next video. Please like, comment, share, and subscribe to this channel. See you in the next video.